So our project is to artificial intelligence to predict cosmological parameters from a single galaxy. So let's talk about what is cosmology. Cosmology is a field that explores universe on a very grand scales, assuming that universe will be isotropic and homogeneous and symmetric in all directions. Using this, cosmologists can explore theories such as Big Bang theory and others.
Okay. The Robertson-Walker metric is the metric that describes the space-time of cosmology. It means homogeneous, isotropic, and expanding universe. It has this form where A is dependent on time and equals to 1 in present and 0 at Big Bang, and K is curvature parameter, which can be -1, 0, or 1, corresponding to open, flat, or closed geometry of universe. Yeah. If you find Einstein equation for Robertson-Walker metric and energy of perfect fluid, then we get the Friedman equation, where h is Hubble parameter at particular time, h0 is Hubble parameter right now, omega r is density of radiation right now, omega m is density of matter, both type of matter, dark and ordinary, omega k is spatial curvature density, and omega L is cosmological constant or density of vacuum. Friedman equations allows us to describe the expansion rate of our universe at particular time, relates to contributions of different different energy components. Each term on the right side represents the influence of radiation, matter, curvature, and dark energy to the expansion of our universe. This equation allows us to decipher evolution of our energy content and determine the main factor driving its expansion. Observations, the large-scale structure of our universe, and microwave and background microwave radiation help us to determine the density of radiation, matter, and so on, omega parameters, and Hubble constant. A grand challenge for 21st century cosmology is to determine cosmological parameters of our universe.
So, goal of our project. Recent studies have shown that even in small studies, we can determine the cosmological information. But how do we extract these parameters from a non-linear theory? And the answer is machine learning and neural networks. So, what is neural networks? Neural networks is trying to represent a human brain with it using in machine learning and artificial intelligence, so to help recognition of patterns, classification, and so on. So neural network has something called neurons. It is interconnected nodes that have something in input, and they do something with the input, some operation, and they have output. So each neural network has 3 types of layers. One is input layer. It has like an input information. Second is hidden layer. It helps us operation to more accurate predict things. And the third is output layer. Also, every neural network has a loss function, which is help us to calculate the loss from real parameters and predicted, and optimizer to help decrease this loss.
Okay. In cosmology, it's very important use observational. It's very important to use observational data for test our simulations of theoretical universe. Artificial neural networks are very strong computational tools to modeling data and so on. Yeah, but also it can be used for classify stellar objects and so on. CAMELS, or Cosmology and Astrophysics with Machine Learning Simulations, is a database with a lot of different simulations of universe. But we will use only one of them. No, only Illuris TNG simulations. There are a lot of them.
So we used 17 galaxy parameters from the Illuris TNG, such as like mass of the black hole in the center of galaxy, star formation rate, and others. So let's talk about our neural network. So it has 17 neurons in endpoint layer. Every layer or every neuron is responding for every parameter that was earlier. Then we have 64 layers or 64 neurons in hidden layer and 1 neuron in output layer. We program our neural network in Python using PyTorch. Our loss function is mass squared error, and our optimizer is Atom.
Okay, yeah. Here you can see the results of our neural network, where x-axis is actual results, and y it's results predicted by a neural network. Ideally, it should be just line x equal y, but unfortunately, for such great results, we need a supercomputers and a really long time, and we can get only this stuff with our laptops and time we get, where our red dots it's predictions of our neural network, and this is our 7% accuracy that shows that this line that's our accuracy that shows that as results actually it's pretty close to that line. Some results are in that line. Yeah, but also it's really important to note that our model is not robust. That means that if we try to test our model in other simulations, not Illuris TNG, or with parameter of real galaxies like our, we can get really strange, weird, and definitely wrong results. It is caused, It is caused by that to make real simulations or real simulation of universe. It's pretty hard right now, and every simulation can get a mistake if we try to use results of these simulations with real world or with data of different simulations. One of possible solution of this is to train our model not only by one simulation, but with data with a lot of different simulations. Yeah.
So what we can do next? Maybe we can predict not from just one galaxy, maybe a couple of galaxy omega matter, or we can predict other cosmological parameters, or we can predict cosmological parameters from dark halos parameters like mass and radius. So there's like a really big thing. What we can do next.
Yeah. We would like to thank to Boris Kanikaev and Marko Vrishkin for assisting us with our project and presentation, to Francesco Navarro for advising us about our project, and also to Alexander Kanikaev and all other organizers and volunteers for providing us such a great opportunity to improve our knowledge. Yeah. If you have any questions, you can ask.
Could you open the slide with second terminal?
Yeah.
Oh.
Wait.
Okay.
Second.
Okay. You mean Friedman equation, yeah? Oh.
That?
Yeah.
This one, yeah?
Yeah.
Okay.
Could you tell these letters R, M, K, and
Okay. R represents radiation.
yeah.
M, no, omega R, it's density of density of radiation. M is matter. K is curvature, and L is vacuum, or it's also named
Dark energy.
cosmological constant. This last
okay.
thing.
So dark energy is matter, I believe,
Yeah.
right? It's
Yeah.
So dark energy is the lamp.
dark
Dark
energy,
matter.
yes, lambda.
Yeah.
Dark
Yeah.
matter is
Dark
an
matter is both baryonic and dark matter
Yeah.
are two matter.
Yeah.
And also one more question. Can you go forward to the graphs that you have?
Yeah.
Yeah. Just a question. Let's answer from my curiosity question. I mentioned that here is at first there was upper this ideal line,
Mhm.
and after they go down, and after
Yeah.
some point they same, they go down
Mhm.
under this line.
Yeah.
Do you have any predictions why it looks
Okay.
like that?
My prediction is that because the main task of neural network is to find some pattern and to show and to predict, and he tried to predict future results with this pattern. So sometimes if we try too much or something, if we try too much, our neural network can find pattern there where no any patterns, so can give us these strange results. This can be fixed if we train our network for much more time or with supercomputers, but unfortunately we don't have such an opportunity.
Okay, thank you very much for your
Yeah.
answer.
Thank you.
boy.
I have two questions. First one is what this triangle brackets mean in this equation? No,
Yeah, right there.
Right there.
Yeah.
The average.
This. No, this is just gaps. I think I don't remember how this.
Right?
Average.
It's like error.
Average.
Can you repeat your question, please?
Yeah, I have. Please.
Okay.
Answer my question. Second question.
Thank you.
In top of this graph, even red lines don't touch
Yeah.
the white line.
Mm-hmm.
Why? Right?
Yeah, I already answered. It was
Wait
Peter's question. Or Peter's question.
One more time.
Okay. The main task of neural network is to find some pattern. And sometimes it can find patterns even there if it's no any patterns. And here, as I assume, our neural network thought that by this thing, it thought that it can be the square root or something like that. And after that, he tried to predict future results, also like square roots.
Okay.
So it's like it gets superstitious.
Yeah. But it's only my assumption. I'm not sure.
Okay. If there are no more questions, let's thank speakers again.